Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. In this video series, we're looking at concepts that experienced programmers know and that often aren't covered in introductory materials. The goal of these videos is to help you form a mental model of what your code is actually doing as it runs. The focus of this second video is flow of control. Let's define that. Flow of control refers to the order in which programming statements execute. Control is which statement is currently executing in a program, and flow is, essentially, where will control go next. An experienced programmer can form a dynamic model of a program from the code. A dynamic model of a program is how it behaves in action as it's running. That's a lot harder for beginning programmers to do, but it is an essential skill. Let's start with the default flow of control, sequential. I have here a program in Python which asks the user to guess a number between 1 and 10. The flow of control in this program is sequential, in sequence, and most people intuitively understand this flow of control without being told. The statements in this program will execute from top to bottom in the script. First, the constant number is defined on line 6, and then the instructions are printed on line 10, and then the guess is obtained from the user on line 11, and then the program displays the user's guess and the number on line 12. The lines are executed in order. Comments and blank lines are skipped, but otherwise, control simply moves downward. If I run the program, I type a number at the prompt, and then the program tells me the number I typed and the number I was trying to guess. No matter how many times I run it, no matter what number I type at the prompt, the same statements execute. Let's look at the next flow of control, selection, as a contrast. Control will flow sequentially in a program unless there is a statement that changes the flow of control. The selection programming statement in Python, and a lot of other languages, is if. Switch is another common selection construct. No matter what your selection construct, if or switch, conditional expressions are used to select a block of code to execute. In the updated version of our number guessing program, a selection statement is used to print one of 3 messages. You guessed my number, your guess is too high, or your guess is too low. Only one of these messages will execute, based on the truth value of the conditions, guess equals number, and guess greater than number. A selection statement interrupts the sequential flow of control, chooses whether to execute one among one or more blocks of code, and then sequential flow resumes once the selection statement has ended. If I run the new version of the program, which output I get depends on the number I type at the prompt. The number I type at the prompt is used in the tests that determine which of the 3 output statements will execute. A flowchart illustrates the flow of control in a program. The boxes in the chart show blocks of code, and the arrows show where control will go next once a particular box has control or is executing. Here's a flowchart representation of our sequential program. You can see there is only one path through this program, one arrow out of each box and one arrow into each box. In the sequential program, each box has control once, and then passes control to the next box in the sequence. The flowchart for the selection version of the program starts the same, with a box initializing the number to guess and a box obtaining the user's guess. But then there's a diamond labeled guess equals number, and 2 arrows leaving the diamond representing 2 different paths control might take. One arrow is labeled true and the other is labeled false, one for each possible outcome of the test. A diamond represents a decision in a flowchart, with a test inside the diamond. The result of this test, true or false, determines which statement is selected to execute next, or put another way, where control will flow. In this example, if the test evaluates to false, we flow to another diamond, and another test with another 2 possible paths. The guess is too high and the guess is too low. In total, there are 3 different paths through this small program. The next flow of control is iteration or repetition. In this version of the program, the user guesses until they guess the number correctly. If I run it, you can see that if I immediately guess the correct number, I'm told I guessed the number and nothing else happens. But if I guess incorrectly, I'll be told my guess is too high or too low, and given another chance to guess until I guess the number. In this program, how often the iterative code repeats depends entirely on the user's input. The most common constructs that interrupt sequential flow of control to produce iteration are while and for, although there are variations such as do while and repeat until. As with selection, the sequential flow of control is interrupted by the iterative construct. A condition is tested, and if the condition is true, a block of code executes. If it's false, the block of code is bypassed. Importantly, in an iterative flow of control, after the conditional block has executed, control returns to the top of the construct and the condition is tested again. If it's true, the iterative code executes again, and then control is returned to the test. This repeats until the test is false. Iteration is where beginners often lose track of the dynamic model. Iterative constructs are a common source of bugs, including off-by-one errors and infinite loops. This flowchart illustrates the iterative flow of control. Once we reach the test guess not equal to number sequentially, if it is true, we go into the conditional code that determines which message will be printed. After printing the message, we get a new guess from the user. We then reach an arrow that goes back up to the test. Iterative flow of control is often called looping because we have this loop shape in the flowchart where we loop back to code that was previously executed. When the test is false, we skip over the iterative code and down to the message that prints, "You guessed my number." This is the sort of code that might make a beginner uncomfortable because the program appears to be printing a message without checking to make sure that the user really did guess the number. To an experienced programmer, though, it is clear that we cannot reach this line of code until the user has guessed the number, and the condition guess not equal number is false, meaning its complement or opposite is true, guess equals number. The final flow of control is invocation, in which control is temporarily transferred to another block of code, sometimes called a function, method, subroutine, or procedure, and that block of code has control until it's finished executing, and control returns to where the block of code was invoked. I'm going to call that block of code a function, but again, it could have a specific name in the language you're using, or context in which you're using it. Functions are interesting because they're defined once, sometimes by you, sometimes they're part of the language, and sometimes they're in a library you're using, but then they can be invoked whenever they're needed in the code. They don't interrupt the flow of control when they're defined. They interrupt the flow of control when they're invoked. There isn't a special jump keyword. It just looks like a name followed by parentheses, and yet control is about to move somewhere entirely different. The name of the function followed by parentheses is used, and control jumps to that code. In this version of the program, I've defined a function called giveHint. Again, that function definition doesn't alter the flow of control. It's when I use the name of the function inside the loop that control will jump to the function code. My loop now looks like, on line 20, while guess is not equal to number, and then inside, on line 21, give hint, open parentheses, number guess, close parentheses, and then on line 22, guess equals int input, guess my number. Every time we have guessed the wrong number and the test is true, we go into the loop body, and the code give hint, number guess, invokes the give hint function, causing control to jump to that function code. Once it is finished executing, control returns to where it was called, line 21. Nothing else is happening on line 21, so sequential flow of control resumes, and we execute line 22. In a flowchart, we show a function as a separate flowchart. The invocation to the function is a box with vertical lines on the sides. The left flowchart here is our original program, and the right flowchart is the giveHint function. In our flowchart on the left, when we reach the giveHint box, control will jump to the flowchart on the right, and it will execute until the return circle. Control then returns to the giveHint box and flows from there. You can think of it as a flowchart inside another flowchart. I have another example of a function call that's slightly different. I've enhanced the program to include another function, generate random number. This function generates a random number between low and high for the user to guess. Notice that this function has a return statement and returns a value, and where it's invoked, it's on the right side of an assignment statement. When this function is invoked, control jumps to the function code and it executes. And when it is finished and control returns to where it was invoked, there's more code that will execute on that line. The value returned by generate random number will be assigned to the variable number. A function call is an expression, the topic of the previous video in this series. If a function has a return statement, as in generate random number, that's where the function returns control to the line of code on which it was called. If it doesn't, as in give hint, then the function returns control once all of its statements have executed. A function can have multiple return statements, but that can make it harder to see the flow of control in a program. Some programmers prefer a single return statement because it makes the flow easier to visualize, especially for beginners. One tool that helps you build this dynamic mental model of a program is a debugger. A debugger allows you to pause a program, step through it one line at a time, and watch variables change as control moves through the code. Instead of imagining the flow of control, you can observe it directly. Debuggers are essential programming tools. Experts know this. In this video, we have covered the 4 standard kinds of flow of control you find in structured programming: sequential, selection, iteration, and invocation. I do want to mention one other way that sequential control can be interrupted in a program, and that's with the throwing or catching of an exception. If I run any version of my program, I'll run the simplest, and enter a value that can't be converted to an integer at the prompt. I'll type the letter Q. The program immediately terminates with an exception: value error, invalid literal for int with base 10, Q. As a programmer, you can throw exceptions when exceptional conditions occur, causing execution to halt if the exception isn't caught, or you can catch them, executing code designed to clean up the mess or fail gracefully if an exceptional condition occurs. Exception handling isn't one of the structured control primitives we've discussed, but it does alter the normal flow of control in a program. I wanted to mention it in this video, otherwise it might feel like magic when an exception occurs and your code does not execute in its usual sequential order. There is no magic. We can always predict which line of code will execute next if we understand the control structures and the current state of the program. I hope this video has given you some expert insight into flow of control. Maybe it explains some mysterious bugs you've encountered and gives you strategies for uncovering how the execution of the code followed a logical path that led to the bug. If you have questions about anything in the video, please drop a comment below. I'm happy to clarify anything that doesn't make sense. As always, have fun and keep coding.